All right. So if you don't have this, maybe just write it down later. Write down, for now, just call it example 1 in your notes, and then start treating this as being part of your notes at least, so you have it. Okay. A company makes backpacks and briefcases. So right there, you should realize that, right? Those are your two variables here. Daily output cannot exceed a total of 40 backpacks and briefcases. A maximum of 20 backpacks can be made in one day. The maximum daily output of briefcases is 30. Draw a graph that shows the possible numbers of bags that can be made in one day. Okay, so we will let X be the number of backpacks and Y will be the number of briefcases. Okay, we will let X and Y be greater than or equal to 0. And again, this is discrete, okay, because it's number of things, right? You can't have partial quantities. Okay, and so we've done that. That's kind of like always like your setup, and then you want to be looking for your inequalities. And let's highlight them. Okay, output, right? Daily output cannot exceed 40 backpacks. Okay? And briefcases. Sorry, it does say both combined. So let's write one for that one already. So it's saying that the daily combined output cannot be, cannot exceed, right? Meaning that it's a maximum of 40 that they can make. So X plus Y, right? The number of combined items cannot exceed 40. Output cannot exceed 40 total combined. Okay, there it is. a maximum of 20 backpacks can be made. That is specifically talking about backpacks. Okay, so what do you think is going to happen there? Backpacks is X, and that has to be less than or equal to 20. Okay, maximum of 20 backpacks. And the maximum daily output of briefcases, right? So maximum briefcases is 30. So that is specifically talking about briefcases. So that has to be less than or equal to 30. Briefcases. Okay. And there we have our system of inequalities. It's actually not that bad. Very quickly write these two are special cases, and then you have just an X and a Y and a coefficient or a constant on the other side, right? So it's very easy to graph. So we can just number it 1, 2, 3 like that, perhaps, right? So 1 here, x-intercept is 40, 0, y-intercept is 0, 40. So you have that taken care of. Let's rewrite it. And this is solid. Below is true. So we'll shade above. Okay, second question. It's a vertical line. And it passes through 20, 0. It's solid. Yeah, remember left and right? We haven't done one of these in a while. But less than means that the left is true. We're going to shade right. Okay. And then we have the third one, which is a horizontal line, and it's going to go through 0, 30, right? It's a y-intercept there. It's solid, and it's less than, so we shade above. And really what I'm going to focus on more in a bit is the coming up with the inequalities. The graphing part, you should be quite comfortable graphing by now. Okay. So this is number of backpacks. Number of briefcases. And if I go 50 in each direction, I'm fine. 20, 40, 60. There we go. I use a scale of 10 on each one. 40, 0, 0, 40. Connect. There's a vertical at 20. There's a horizontal at 30. Oh. And this line right here, x plus y is less than or equal to 40. Now let's shade in. First line, we shade above. You just follow that slanted line, and so everything above that line is gone. Okay. There we go. And then we shade to the right for the vertical. That gets rid of this little triangle that was formed down here. And then we shade above for this horizontal line, which gets rid of this triangle yet that was open. Okay, so everything past that was gone anyway, so let's make sure we know what is not a solution. So right here is your solution polygon or solution region, right? Same thing. Corner points, 0, 0, of course. And we can read a lot of them, right? 20, 0. We can read that one right there, 0, 30. These two we might need some help with, right? How would you do those? Well, let's type them in. So we've got x plus y. Sorry, that is, we never rewrote, did we? Oh yeah, we did, okay. Negative x plus 40. And then we can't graph the vertical, but we can graph the horizontal, right? So you graph that. So this, let me scroll up a bit here. So this is that one right there. So we can find that intersection, 1030. And we use the calculator for that, just making a note there. And then this one here, how would we do that one? Second trace 1, and it's x, right? X is going through here, so we're going to type in x is equal to 20 and then get 20 there. So it's 20, 20. Coincidence. All right, so 2020. We've got it all figured out. They're all round numbers. No need to round up or anything. So we're good. And these are the corner points from which we're going to extract our ultimate answer down the road. So it is basically, I mean, I would actually like to take this opportunity to do that to find the maximum, but I think I'm just gonna leave it for now and just stick with what the plan is. Just answer the question as is. But one of these is ultimately gonna be the best solution. They will have to give you a little bit more information, but there it is. How could they have, look, we're just under 10 when we were done this, and this with explaining stopping. How could this, what else could they have thrown into this question? So let's say, Mr. Dirksen, I would like to make a question and kind of using this as my backbone. What else could I have thrown in there, right? I could have said that, it costs, $2 to make a backpack and $3 to make a briefcase. And the company would like to spend no more than, a couple $100. If that were the case, right? Like, oh, wait a minute, now we're talking money. There should be a coefficient, right? The $3 and the $2 or whatever, $4, whatever I mentioned, that gets integrated into this. And so think critically, what is happening here? Do I need a coefficient other than 1 in front of x and y? Is this only speaking to x, or is it only speaking to y, or is this a combination where it's both being mentioned, right? So those are the things that you want to look out for. Okay, let's go to example 3. So we'll do example 3 here. So if you don't have that handout, this was posted on Thursday. And here we go. Okay. Again, I wanted you to give this a try already, and you've had time to do so. So I did notice that there was a bit of a spike on the video on word problems, which is a good thing, like you were trying to grasp that concept, and that's very good. You need to practice, okay? So when you feel like I need more examples, well, you need to try more, right? I can't just keep on giving you examples. You need to try them and see if you can come up with the answer. Okay, example 3, Alyssa plays soccer and baseball. Guess what the variables are going to be, right? Something to do with soccer, something to do with baseball. She burns 4,000 calories an hour playing soccer and 50 calories an hour playing baseball. Each week, she's willing to spend at most 18 hours exercising and wishes to burn at least 4,000 calories. Draw a graph to show the time Alyssa could spend on each activity in 1 week. So X will be something, Y will be something. You can't just put soccer down, right? It would be kind of weird. Let X be soccer, let Y be baseball. Like, wow, how would that even make sense, right? So there you have to kind of think what makes most sense here. Would it be, calories burned playing, or what would make more sense? Well, here's where the key is. When you have a question like this where it's not just a number of, backpacks and briefcases, like that one is pretty easy to determine. Look for, in this case, it says 400 calories. It could be, dollars, whatever. 400 calories per hour of playing soccer and 50 calories per hour. That right there is what your units have to be, because you're going to try to figure out how many hours would get you there, right? So this would be hours playing soccer and this would be hours playing baseball. All right, so and x and y has to be greater than or equal to 0. And what kind of data are we talking about here? Well, it's hours that can be measured. So this is actually continuous. Right? You can have 0.5 of an hour, you can, right? 0.4 of an hour, you can, in theory. Now let's come up with our inequalities. Let's read again. She burns 400 calories an hour playing soccer, 50 calories an hour playing baseball. No restriction there. Let's keep reading. Each week, she's willing to spend at most 18 hours. So there it is. Spend at most 18 hours exercising and wants to burn at least 4,000 calories. Okay. So the at most or has this much available, or, when you notice that there's a bit of a limit or a minimum, right? Like you want to have at least this much, then okay, that there's going to be an inequality that will have to fulfill that. Okay. So we're talking time at most 18 hours. Given that X and Y are hours being playing the different sports, that means that whatever combination is going to happen, you're going to have to add the number of hours spent doing each, right? It could be 0 for one, it could be 18 for the other, but the combination has to be less than or equal to 18, right? Because you have at most 18 hours combined, right? So that's a restriction there. Doesn't matter what you would like to do rather, but the combination has to be less than or equal to 18. Then burning at least 4,000 calories. So we're talking calories now, and notice that there are coefficients, right, that talk about calories. So in this case, you would say, hey, 400 calories per hour playing soccer and 50 calories an hour playing baseball, right? That combination, you would, right? Like if you played 10 hours soccer and didn't play baseball at all, you would be uh, burning 10,000 calories, right? So that is one possible option. But whatever the combination is, this is going to give you the calories you've burned. But that has to be greater than or equal to 4,000. Okay, that's it. Only two inequalities in this case. If this question had mentioned, since soccer is, is her favorite sport, she would like to spend at least, right, 5 hours playing soccer. The rest doesn't matter, right? If she wants to,
4,000. You put 4,000.
Yeah, that's what, right? That's the minimum. You wanna burn at least 4,000 calories. So the combination here is at least 4,000. Make sense?
I didn't read the last part. Sorry, I didn't put that down.
Okay. So I'm always trying to get you to think, okay, not just to copy and oh yeah, let's just apply this, because it won't work for you. You know that already. You have to kind of think and come up with generalizations that you can kind of take and apply, but it's not always going to be the same. So if the question had said, wishes to spend at least 12 out of the 18 hours playing soccer, ooh, that is a restriction, right, on the amount of hours played soccer. So it's going to be a vertical line in this case, right, because it's only applied to X. And so you got to kind of be very pay close attention to that. So let's call this 1 and 2. Saves us a little bit of time. For the first one, x-intercept, y-intercept is fairly simple, right? That would be 18, 0, and 0, 18. That's when it's one of those x plus y and a constant on the other side. You can guarantee be guaranteed that that's going to be the case. Solid above. And for the second one, x-intercept, y-intercept, you have 400x is equal to 4,000. Divide both sides by 400. X equal to 10, so that's 10, 0. And here you have 50y is equal to 4,000. Divide both sides, that's 80. And so that's 0, 80. Then you have 50y is greater than or equal to a negative 400x plus 4,000. Divide everything by 50. Nothing flips, okay? It's negative 8x plus 80. Solid and below. Right? In this case, above is true, so we shade below. Graph. Hours playing soccer. Notice that you're adding your units and you're labeling when you do that. Hours playing baseball. And if I go, I need to go up to 80 here. But if so I'm just going to do the same on both 4, 5, 6, 7, 8, just barely, but I made it. If it doesn't, then you just change your scale, right? 4, 5, 6, 7, 8. Okay, there it is. 18, 0, 0, 18. There's that. And then it's 10, 0, 0, 80. So that's what it looks like. And let's label this one as 400x plus 50y is greater than or equal to 4,000. And this one right here is x plus y is less than or equal to 18. It says shade above for this one. Everything above that line is gone. If it doesn't work for one, it doesn't work for the whole system. Okay, and then it says to shade below this line. Okay, so you basically shade below everything. No need to do that, but yeah, basically you're shading everything below this line. So this is your solution. Make sure you label that. Corner points, let's do the ones we can read. 10, 0, and then it's 18, 0. And let's find the intersection there. I think I'm going to fast forward to whatever I have for the key here. And that would be 8.96, 914. And this is a calculator, right? We can leave it like that because it's continuous data, and so we won't touch it, okay? Will your graph look a little different? Perhaps if you use a different scale, but that is not a big deal at all, okay? As long as you're consistent, that's all we care about here. Okay. I'm trying to think here. Of the one. Okay. I want to see if you have this worksheet. If not, I'm going to have to post it. So you're going to have to let me know. Let's just stop the, this goes here. Do you have this handout, folks? If a couple of you can look through your package, it looks like this. Can I get a confirmation if you know, half a dozen, like if you just raise your hand if you have it. Look through it. If not, I'm just gonna post it. Not a big deal. Okay, hold on. Cassie says you don't have it. Okay. It could be like I made this one fairly recently, so okay. That's what I figured. I figured that this one was a newer one. I forgot to put it under my order for printing. So yes. Okay. So this is the homework I'm going to give you, okay? It's going to be this handout right here. So for those of you who are going to watch this later, maybe that's the second question because you can always pause the recording and write it down, right? And so I'll tell you that, you know, one has 2 inequalities, one has 3. So to gradually up it, right? So I'm going to stop the recording.